Yeah.
Okay, cool. So let's start then. All right. So hello, everybody. Thank you very much for joining us tonight for this meetup about machine learning operations using with a feature store. I'm Gianmario, and I'm one of the founders of the Data Science Milan community. I'll give you a brief introduction of our community. We are an independent group that was born in February 2016. Nowadays, we have more than 1.6 thousand members, and we meet every month, roughly, physically or online. The staff is the following. We just had this new entry that is Marco in the bottom right as a technical coach. So you will hear from Marco in the next following weeks about his ideas and initiatives to create more engagement around technical topics and conversations among community members. So stay tuned. In addition to the people that currently manage the whole organization of the community, we're also looking for extending the staff with new members, people that want to help. And in particular, we are looking for a social media manager. We already have Marco, the other Marco, that is currently managing all of our social channels, but he needs somebody else to also help with, we have many channels, so we need more than one person to help with that, and also we'd like to start creating contents for our website. So if you're interested, you can talk with one of us, or you can send us an email on datasciencemilan@gmail.com or visit our website, datasciencemilan.org. You go on our website, you're gonna find the link to the blog where there are all of the summary articles for all of the previous events. So if you missed one event, you can read the summary on our blog. You will also find the recordings and the slides. So everything we do is recorded, so even if you cannot attend one event, then you will find everything on our website. And if you want to start a conversation, you can go on our Slack, and then you can ask questions to other people. Just to give you an update on the next events, we have not decided the dates yet, but we are currently talking with a speaker, Haris from London, who will give us a talk about conversational AI. And we also been speaking with TensorWorks, that is a company of aerobics, that will show some of the tools they've been building for managing the machine learning lifecycle. If you have not registered on our newsletter, you can go on digest.datasciencemilan.org. We have Ricardo, that is our newsletter manager, and he selects every month just what is relevant in terms of events or discounts, promotions, or interesting tutorials, news, libraries, papers. We only send this email once a month, so please join if you have not done that yet. And if you want to keep in touch with the other community members, you can go on we have our Slack group. You can go on our website, and then at the bottom you will find a new user, request an invite, so you can type in your email address and you will receive an invitation. Yeah, and then I can read from the comments. We have Nicola, who is our star member, is the most active member in the community on Slack, and then he's really looking for other people to engage with. So do that. If you want to send your own proposal to that, we're open to anybody, especially now that we have webinars. We don't need to find locations. We don't need to have a venue for hosting the event. So it's going to be, everything is going to be very easy. So if you have any topic you like to share and discuss, then send your proposal. Okay, Wallboard. I don't know if all of you knows that Data Science Milan is now part of the Italian Association for Machine Learning, together with other meetup groups or other communities. It's a very interesting project for collecting all of those group of people that work on, we share same passion for the topic of machine learning, data science, data in general. I sent an email I think 10 days or maybe a couple of weeks ago. This has nothing to do with data science, but I found it worth to share with everybody, since that now is a tax return period. So we managed to get this 20% discount for all the community members. You have to go on the website. There is an article with the form you can fill in, and you get this 20% discount. It's for with the commercialista in Italiano. I want to promote a couple of events that are coming up very soon. One is the European R users meeting that will be in a couple of weeks online. So actually it says meeting comes to Milan, but actually it's an online event. So even if you're not from Milan, because we know the webinars, the web meetups, we also invite people from outside. We promote on every channel, so you can join as well. And same thing also for the AWS Summit. It's going to happen on June the 17th. Okay, so let me give a little bit of promotion for one of the companies of our community network, is Aerobics. They are looking for a data scientist with a couple of years experience in deep learning and healthcare. They're also opening an office in Milan. So if you're interested, you can either go on their website or you can talk with me, send us an email, and then we'll create the link. We'll make you in contact with them. If there's any message you like to promote for one of the next event or in the next newsletter, send us your correspondence. Okay, that's it. So the agenda of today is we're gonna have Fabio, I guess from Stockholm, correct? Where are you from?
Yeah. I'm based in Stockholm.
So we have Fabio from Stockholm that will give us this overview of the feature store. They built logical clocks. I think this is also a preview of Spark Summit event.
Yeah. There is a Spark Summit. It's at the end of June. So it's kind of a similar. They talked on the similar topic basically. So yeah.
Excellent. So you should feel very glad that you can get this talk,
like in
advance as a preview. Okay, before we start with the talk, just need to ask you a favor. So we are a community of volunteers. We don't make money out of this. We do this because we're passionate about. So we need your help to support us. And the way you can support us is by going on our every one of the major social networks, the one you prefer the most, and please share the pictures, tweet about us. So we need to spread the word. So this is the way you can help us. Thank you very much and enjoy the event.
Okay, thanks. Let me see if I can share the screen again without crashing the browser. Okay, so let me. So thank you for having me. As we said before, I'm Fabio. I am Italian, but I'm currently living in Stockholm. I'm going to talk about MLOps and how to do MLOps with a feature store, what is a feature store, and how to use it. So in particular, we're going to focus on the OpsWorks feature store, which is the feature store that we are building at Logical Clocks, the company I work for. It's an open source tool, and we also have a cloud platform that you can use and try it. So what is what is a feature store? What is MLOps? So the MLOps is the idea is that we want to apply kind of like the same concept as traditional, let's say, software engineering development to machine learning. And if you try to do that, you will soon realize that not only you want to have your model code, your feature engineering pipeline, and everything on Git, but you also want to have a way of tracking and sharing and being able to find actual features and feature data. And that's the idea behind the feature store, being like a repository, like you can imagine a Git repository, but for feature data, where people can and user can push the data, can push features and make them available to other user, and generally within an organization. And so this is like a standard end-to-end pipeline for machine learning. So going from the left side to the right side, we have data coming in, whether it's a CRM system, whether it's sensors, whether are like a database. They just end up being pulled in either through Kafka or like to whether a process is to a data lake. And data lake is where everything arrives, and it's used both usually to feed the data for machine learning pipelines, but it's also used to feed the data for traditional like data analytics and like dashboards, visualizations, and so on, like tools like Tableau and Click and so on.
So Fabio, may I interrupt you just for a moment?
Yeah.
Because I think we have a technical issue that we only see the cover slide. We're not seeing the other slide.
Okay, can you see it now? Or wait, let me try to share it again. Can you see the slides now?
Yes, now yes.
Okay, I keep it like this. I hope it's gonna be fine, I guess. So yeah, that's what I was saying. We have on the left side the data coming in from different systems, end up in data lake, and data lake have then the source for data for feature engineering pipeline. So taking this data and make it such that they can be used by machine learning models. And finally, the models get trained. There are like several thousand frameworks to do that, and then the model gets served in production, and clients can do inference requests and so on. And there is like typically 3 different figures working on this pipeline. There are data engineers taking care of the first part, where you basically are writing the pipelines to ingest, store, and create features. There is a data scientist, which is basically just building models, even though sometimes they also create pipelines and feature pipelines. And finally, the ML engineer, a figure of ML engineer, which is more DevOps version, where make sure that the models are online and serve requests to the users. And in particular, I want to focus about this area, the feature engineering pipeline, which is where the feature store is gonna enter in the picture and help with the pipeline. The main issue here is that oftentimes what we see in organizations is that the feature engineering pipeline is a bit of a mix between data engineers and data scientists. It's quite confusing. So there is like several data scientist team within an organization, oftentimes building the same features, not sharing across them, building in such a way that they are personalized to the model they are actually working on. So they can't be reused, and oftentimes they're not really materialized. So every time a data scientist wants to build a new model, or they want to explore new architectures and so on, then they will have to start again from scratch on building feature engineering pipeline. And this is like time consuming and oftentimes frustrating for data scientists. So that's actually where the feature store comes into the picture. It solves many three issues. Like, so as I was saying, oftentimes we have data scientists building up features, specific like one-off features. They go look at the data, build up a feature, and then they use it to train a model. And then next time they need the same feature again, and they go again and recompute the same feature again. And this is one aspect. It's time consuming. Oftentimes these features takes hours to compute, so it's time wasted. You have several teams building the same features. So the idea behind the feature store is that you basically create this repository of features. So if you are the scientist, you build the features, you can share it with the rest of the organization. So if you make an example, if you are building a model to predict if a person can get a loan or not, you're probably going to be looking at the size, the amount of money the person had in the bank account for the past X months. But you will probably reuse the same feature over and over and over again. So it doesn't make any sense to, every time you need it, go to the data lake, build up the entire history of the user transactions and compute the size of the bank account. It makes sense more than you have this feature stored and ready to be used whenever you need it and whenever anybody else in the team actually needs it. And so the feature store becomes kind of like the split between the data engineers and data scientists, where data engineers take care and are responsible for everything that ends up in the feature store. So all the pipelines that actually consume data from data lake and actually write in the feature store, and the data scientists actually only go to the feature store and pick whatever it's available for them to use it without writing any complex data engineering pipeline, and focusing on building models and training them. And again, this is finally, if you put back the platforms to do traditional data analysis and dashboards, then they keep pulling from data lake without being affected from the feature store at all. Feature store, we have OpsWorks, Logicworks, we're building OpsWorks. It's open source. It was the first one to be open source. But there are plenty of others that are available. Most of the hyperscaler AI companies have some sort of feature store in place. Uber, Airbnb are probably the most famous ones. But yeah, Facebook, Netflix, and so on. There is a website called featurestore.org, which contains a lot of resources in terms of presentations, in terms of blog posts and articles to explain the different feature groups, different feature store architectures, and how they work basically. So if we analyze, if we take the feature store from a data engineering perspective, the idea is that you have this feature store pipeline pulling data from different systems. They usually, the data usually is not ready to be used by machine learning models. It needs to be processed. Processing examples can be, you have a categorical feature which are basically strings, and you probably want to transform into numbers. You can take a feature and do apply one-hot encoding on top of it. Or you can, for instance, in this example, we have normalization. You want numerical stability in your data so that it doesn't cause problem during the training. And this basically, what you can do is basically, apply these transformations that you will always apply over and over and over. And instead of every time applying them, they just write them into the feature store so they are available, and everybody knows that the data they get out of the feature store is high quality, and they don't have to do any processing whatsoever, and just go there and use it basically. This is one aspect. So making sure the data is correct, making sure that the data is ready to be used is one aspect. The other aspect is if you try to apply, if you take the entire pipeline and you get the model to production, which hopefully the end goal of you building models, you will have clients actually asking for inference requests to this model. And if you go back to the example before of like, can a user trying to apply for a loan, you have like a client send you like 10 features or something like that. So the information that the client knows about it. Unfortunately, maybe like your model has like 1,500 features, or like 2,000 features, and the rest of the features need to come from the feature store. Like all the historical aggregations, all the windows, and so on. They are all pre-computed from backend systems, and need to be made available to complete the inference vector before doing the inference. And here becomes a bit of an issue because the same features needs to be on both systems, and the same features not only have to be available, but they also have to be in the same format. So if I apply a transformation to a given feature, the same transformation needs the same features with the same transformation needs to be in the training data set that train the model, but at the same time it needs to be on the available during inference time. And so this is actually why, for instance, we separate our feature store into online and offline feature store. So the offline feature store is mainly meant for training. So data scientists go there, pull the features that they need, and we see later how you can do that, and build training data sets to train their model. At the same time, the same data is also can be ingested into the online feature store, so that it can be available for applications to use. And this is like this is iterating what I was saying now. It's just like you're working with several time horizons here, both on the ingesting into the feature store and also pulling out of the feature store. So you have like different system producing data at different rates. You have like sensors producing data with extremely high frequency, and at the other end of the spectrum you have a monthly file that arrives from an external system that contains, for instance, I don't know, the last month of the transactions, and everything needs to be processed, and everything needs to be ingested into the feature store so that you can pull data from the feature store. And even pulling, as I was saying, we have different time horizons as well. We have online applications that are maybe user-facing, which require extremely low latency because we don't want the user to wait. But at the same time, you also have training models, which trains on a larger subset of larger data set, and requires more processing power. But at the same time, the data scientists can tolerate higher latency, let's say. So that's why, for instance, like and honestly, like there is no right now the feature store is essentially a database, and there is no database that can offer both of them. Like you cannot. It's really hard to find a database that find extremely low latency at the same time can scale to petabyte of data. That's why we have a separation of concern of like offline and online feature store. So data gets on both of them, but like the way you query them becomes it's different basically. And in OpsWorks, we have support for a bunch of frameworks, so you can write your pipelines in either pure Python or Flink or Spark applications and so on, and then you write this thing to the feature store through our APIs. We have a bunch of APIs both in Python and in Scala. This API are basically a wrapper around dataframes API in Scala for those of you who are familiar with Spark. And so then data ends up in the feature store. Here we have an example of how you can do that. So basically, you import the library. This is a PySpark example. You import the library from the feature store, and then you do just do some data engineering here. It's just a comment, and then you create a feature group, and you pass it Spark data frame. You give it a name. You can give it a description. You can decide if this feature group needs to be make it available online or not. Offline is always enabled, so it's just an additional flag that allows you to make it enabled online. Let me go back here. Okay. So this is like for data engineers. So this is when this is kind of like ends up the part from from data engineering perspective. If you are a data scientist, on the other hand, the way you use the feature store, you go on the feature store and you look up for features. Like features are what we consider like the building blocks on top of like everything else gets built up. So in this example, we have a data set regarding the passengers of the Titanic. The idea is that you have a bunch of features that already be prepared, and features are grouped into what we call feature groups. So feature groups are defined basically as a set of features that have a common identifier. So in this case, the name of the person. In case of the bank example before, it can be an account ID, for instance, or a customer ID or something like that. So some sort of like a unique identifier for each entry in a specific feature group. And the idea is that the feature groups can be then joined together, and you can select a subset of features and then create what's called a training data set. So data scientists go, pick the features they need, create a training data set, and the training data set can be saved in a ML framework friendly format. So for instance, if you're using TensorFlow to train your model, you might want to save it in tfrecords, but you can also save it in CSV, NumPy, and so on. And this is all taken care of by the API. We see that in an example. So data scientists have a pandas-like API where they can they can pull data out of the feature store and write it directly into either S3 or OpsFS or any other external system, and then it can be used this training data set to train the model. At the same time, we have APIs for basically if you during inference period, at inference time, you can go to the feature store and say, okay, give me the trained vector for this specific user for this specific trained data set, and this will allow you to pull the same vector that you use to the training data set. You can use it during inference time, basically. And and you can create multiple versions of feature groups, multiple versions of training data sets. So you can go back in time and you can say, okay, how did the training data set look like a month ago, or like 2 months ago? If you have issue with your models and say, okay, the model is not performing good enough as it was like a month ago, the data changed in the previous month. There can be a useful information when debugging this type of problems. And as I was saying again, it's a Python API. You can use it. It's actually a PySpark API, so works on top of a Spark application. So here you basically on the second line, you're basically selecting a bunch of features. So in the example of the train data set of the Titanic, the idea is that, for instance, like I'm working on a model. Let's make it. I'm working on a model to determine if a Titanic passenger was going to survive or not. And the hypothesis here is that if you can get access to the passenger bank account, we can join them together to determine the likelihood that the passenger actually survived. And for instance, another team, my same organization, was working on the passenger bank account feature groups. So I can go on the feature store and look and search for features and find this data set, find this feature group, and join them together to create my full training data set. And so this is what like the code look like, right? So you get I got a bunch of features. I want name, the class, the sex balance, and if the label in this case, if it survived or not. Here the idea is that because we, as I was saying before, because we have feature groups with a unique identifier, the API are going to help you in determining how to join these features together. So from a data scientist perspective, you don't really have to bother about how are we going to join these features together? Can they be joined together and so on? So the API is going to help you in that sense. And this will return your data frame. You can select, I can show more code later. You can select the type of data frame you want back. So you can have a Spark data frame, you can have a Pandas data frame, depending on what you're doing, and then feed it into the create render dataset method, which is basically taking a dataset, it's taking a name, a description, which format you want to store the data, and which version you want to version number. So you can have multiple versions, as I was saying, and then go back in time and determine if the data changed and what effect had on the model. We'll go back here. Yeah, so as I was saying before, this is same API for online and offline, but I was saying before, like we have the separation of concerns where we have on offline feature store, which basically allows you to do like build up a large training data sets, and as high latency, of course, but allows you to work with larger quantity of data. At the same time, we also have the online feature store, where it allows you to work with like small amount of data, but really fast. So it's useful for online applications, basically. In OpsWorks, we use something called MySQL NDB, which is like a low latency distributed in-memory database. So you can deploy it in a high availability setup. The way you're going to interact with this online feature store, it's similar to the API that I was showing before. The idea is that your application, that your client goes to the online feature store and says, okay, I need the training vector, I need the inference vector for this specific user and this specific training data set, and this will return back a query which you're gonna run against the online feature store, and they're gonna give you back the data, which you can then give it to the model and complete your inference vector to do inference, basically. As I said, it's low latency, it's in memory, it's quite fast, especially if you're doing primary key lookups. If we go back, like this is like feature store is a component of the OpsWorks platform as a whole. If you go back to the idea of like how to build ML pipelines from end to end, OpsWorks provides a lot of blocks to do that. Of course, these blocks can be some of them can be replaced. For instance, if you're already doing machine learning on other platforms, then you can still use the feature store from other platforms like SageMaker, for instance, and interact with the feature store. But OpsWorks provides that capability as well. So the idea is that like you have access to Kafka, you have access to Spark and Flink if you want to do the engineering. Of course, the feature store is a big part of it. OpsWorks also provides bunch of libraries and support for basically the most important frameworks to do machine learning and in particular deep learning. We have access to Jupyter Notebook, TensorBoard if you're doing debugging of your models and so on. And finally, model serving and how to monitor your model in production. The entire pipeline is usually orchestrated in Airflow. So you have DAGs or steps. So we say, okay, ingest this data, update the data in the feature store, and then when data is updated, you kick in another job, which basically pulls the data, create a data set, retrain the model, evaluate the model. Is the model good enough to be replacing the existing one? So if so, then push it to the serving platform and start monitoring again. The entire platform is supported by HDFS, which is our file system metadata. So we can do stuff like implicit provenance. So you can track the entire flow of data from ingesting to training. So basically, you have if you are building a model, we can see which models, which data you have used, which training data set you have used, and for which training data set we can see which features actually compose this training data set. And so we can construct the history and show the history of the entire pipeline. And so if you unwrap this thing and build up the entire pipeline again with the feature store, the idea is that, again, data comes in from external systems, and the data is stored into both the online and offline feature store. You might decide to store only a subset of the online feature store. So maybe on the offline, you have like, the last, 3 years of data, but the online, you only need the last 6 months, for instance, on like 3 months or something. So that is actually up to the user and during the feature store and feature engineering pipeline to decide. This data is again pulled out from the scientists during the feature selection phase. You train the models, validate the models. That is okay. You publish the model in the OpsWorks model repository, which you can then use to serve it and deploy it on the serving platform. And online application can pull data from the online feature store, pull the feature store feature vector for a specific trained data set and a specific user, let's say identifier, and use it to augment the vector. OpsWorks, I was saying, it's not only the feature store. There will be a bunch of more tools there, especially when it comes to distributed training and distributed hyperparameter search. We have another talk that we mentioned at the beginning. That this is kind of a preview of a talk we're going to give at Spark Summit coming up in end of June. And we also have another talk regarding Maggie, which is a library that we have built on top of PySpark to do both hyperparameter search and distributed and ablation studies. So it's again open source as well, so you can check it out. And we have also supported a bunch of other stuff, so I can show you a demo now on the platform and see how it looks like. The idea, we have projects with way of managing data, way of managing Kafka topics, way of managing Python dependencies. As I was mentioning before in the slides, we have a way of tracking the metadata, and so tracking the provenance of the data coming in. So depending of your model, which trained data set you have been using, which features are part of that trained data set. Yeah. So this is first part. I have a small demo. I want to show you a little bit of the platform. So we have, the platform is open source. You can download it and install it. We have a community. You can go on. Let me see. Go back to the slides. We have a community platform. Present here. Community.opsworks.ai, which allows you to, you can ask questions and have support, community support for that. All the code is available in OpsWorks on the Logical Clocks GitHub repository. But we also have this kind of managed platform that allows you to, just try out OpsWorks. So I already have deployed a cluster. So this is how the platform looks like. As I was saying, we have a concept of projects. The idea is that you can separate data within different projects, and projects cannot access each other's data. So if you are in an organization and you are let's say working with sensitive data or non-sensitive data, then you can separate this data in such a way that people that do not have access, do not need to access to sensitive data, do not get access to sensitive data, basically. So we have a bunch of tool projects that you can run to learn about the platform itself. I'm going to focus on the feature store one. So this is, in particular, this is the feature store coming in. We have a bunch of features groups available here. So here you can see which one are available. You can search for them. But at the same time, if you are the scientist and you're doing you're building a model and you need to figure it out which features you need, we have many more tools available. For instance, when we build feature groups, we collect statistics about it. So over given feature groups, we have access to stuff like what is the correlation between the different features within the feature group. So you can pick, it's probably I probably can drop one features because there is no point of having both of them, because they are highly correlated. We have statistics like, what's the number of values that are available, what is the minimum, maximum, average, standard deviation of the different values that are part of the specific feature. What is what is the distribution of the data within a feature? So all these things actually can help data scientists to pick specific features that they need for decide whether or not they need that specific features. And you can also, without writing any code, you can also get a feeling of what the data looks like actually. So you can just have like a 10, 15 examples of data. You have an idea of like, okay, what does the data look like? Is there an integer? Is it actually a string or whatever? So this is actually how you can interact from the UI, which is we found it really useful. So you don't have to you can basically do everything from here basically. Here you can search for individual features. You can find out which feature group they belong to. And at the same time, you can use the same UI to build a trained data set, for instance. So now I need to pick, I don't know, I'm building, let's pick these three. Create a trained data set, just give it a name. Put the description. And I don't know, you select the different format I want to select, and then I want to store it on it's okay, I store it on the internally on OpsWorks, but I can also decide to store it on the on S3, for instance. If S3 was configured here, I don't have any S3 connector configured, so I can only store it here. And then create it. This will behind the scenes create a job for me. And then I can run this job to basically create a trained data set, and then I can put this job in an Airflow DAG, and then every night or like every X amount of time, I can decide to rerun the job to regenerate the trained data set basically. And while all the UI is nice, maybe I'm biased, but I think it's nice. We also have support for, as I was saying, the both Python and the Scala APIs. So we have support, like you can, from the API, you can basically do the same operations that you do from the UI. So for instance, you want have an idea what a specific feature look like. You can go in the feature store and say, okay, I want to create, get me these features from the feature store and show me, five values. You can go like way more complex. You can say, here you can say which feature groups it belongs to, the feature store it belongs to, and the idea behind this is that if you're working on an organization, you probably want to separate the production feature store and the development feature store. So I can have an example. So you have here, you can have two feature stores basically. The production feature store allows you to, it's read-only. People can. Data scientists have access to it. They can pull features from it, but they cannot create one. They cannot remove features because those features are going to be needed for pipelines that are online, and you need to have certain SLAs and so on. So the idea is that you can share the production feature store with like a development feature store, and the data scientists are free to experiment with new features. And when they are happy with the results, they can publish. They can ask and that the feature is published on the production feature store. And here, this thing basically allows this specifying the feature store allows you to pull features from both of them, from the production and from the development one, so that you can join them together and create a trained data set. As I was saying, you can specify which type you want. If you want a Spark data frame, you want a Pandas data frame, you want an NumPy array, for instance, and you can do that. You can specify the different types. You can fetch entire feature groups, and you can also, if I go down, you can also interact with statistics again. All the statistics that were available in the UI are also available from the Python API. So you can do visualization, and you can even do like more visualization than what we support natively in OpsWorks. You can build your own dashboards and so on and so forth from this point. Once you're happy with your set of features, then you go. Let me see if I can have an example. Once you're happy with your set of features, you create a training data set. Feature groups. So downstairs. Yeah. Okay. Yeah. So you pull the set of features that you're interested on, and as I was mentioning before, the APIs are smart in the sense that they're going to help you in finding out how to join these features. These features come from different feature groups, but you don't really need to worry about where they come from. And you can put it together and create what's called a training data set. For training data set, we also have support for statistics. You can decide to disable them, so you can also for feature groups you can decide to disable them. Specify the version and specifying the format you want to store it here as well. And you can say, okay, I want to store it in CSV, and yeah. As before, you can decide also which feature store you want to publish this thing. If you have access to the, for instance, as a user, you have access to the production feature store, you can decide also to publish into the production feature store. And yes, that's pretty much how you can use the feature store. There is we have tons of examples on GitHub, so you can go around, you can try out Opsox.ai for free, and you can have an idea of how a feature store can work and how you can use it. That's conclude my talk. I'm happy to take any questions if there are any.
Thank you very much, Fabio. I think if people want to ask questions, you can use the chat, or you can simply, I would say let's use the chat so at least we can go through the same order of question. And I would ask Fabio just one thing, that before to answer any question, if you can read the question aloud, because we are recording.
Yeah, absolutely. Yeah.
Thank you.
Yeah, okay. Is it possible to manage our features partition and shuffle again? Yes. Sorry, is it possible to manage how features are partitioned to reduce shuffling during join Spark stages? Yes, you can. When you create a feature group, let me go to the example how to create a feature group. You can specify the partition keys, for instance. So this is actually the way you have the standard way you will control how data is actually laid out on disk. Let me see. Where's an example? Yeah, partition by score. Yes, exactly. So this is an example of how to create a feature group with a specific partition scheme. You can pass a set of keys. For the online feature store, it's also important to pass the primary keys. Of course, primary keys are not enforced on the offline feature store, but they are important on the online feature store for performance reason. Usually we'll look up for primary keys, and the online feature store, in particular NDB cluster, performs pretty well if you look up stuff for the online by primary key. So, for instance, if you have an account ID and you always search for an account ID, then you can use that one as a primary key, for instance. Is it possible to manage or visualize cover and shift of features between labeled data, user training, and inference data? So the idea is that we in Opsox, when you're serving a model, every time you make a request, the request is logged in a Kafka topic, and then you can have a custom application. We have some skeleton examples on GitHub as well, where you can basically pull data from this Kafka topic. You get the request coming in, the response that the model has returned, and so you can apply your custom logic. And at the same time, you can also access the statistics from the feature store, so you have an idea of how the data has changed over time when you're serving the model. It's not, let's say, it's not automatic. it's not automatically set up for you, but you can have this application to implement this thing basically. Synapse example so which type of storage you're under? The feature store, HDFS for the online part, key value store, which thanks. So for the offline feature store, we use Hive, which then stores data on OpsFS. OpsFS is a fork of Apache HDFS. The main technical difference there is that you basically have distributed metadata. So differently from HDFS, the name nodes on OpsFS are stateless. And so you can have like higher scalability and higher throughput than traditional HDFS. But the API is still the same. So you can use whatever library works on HDFS works also on OpsFS. For the online feature store, we use something called MySQL cluster, which is not a cluster of MySQL, but it's basically MySQL with a specific storage engine called network database, which is a distributed online in-memory database. It behaves a lot like a key value store, but it has actually relational data on top of it. You can have actually schemas and stuff like that. But if you are looking for, if you're querying for primary keys, for instance, that behaves basically as a key value store. You mentioned a lot of AWS services. You already have seen OpsWorks open source version deploy on Azure. Yeah, so the OpsWorks.ai allows you to deploy stuff on AWS. So allows you to deploy a cluster on AWS. We have a bunch of documentations I can show you. You can use this script, which is a bash script that pulls down all the dependencies and all the installation. Also on Azure, we have a specific section of the documentation. Right now, this one. Sure. Yeah. There's something to be regarding the network configuration, but otherwise you can just use the installer that's available here. But yeah, if you go on opsworks.readthedocs.io, you can find the documentation how to deploy it on Azure. And also, I was mentioning before, community.opsworks.ai if you happen to have any question or something fails during installation and you need help with. How could evolution of schema changes index? How could you support the evolution of schema of changes index granularity of a single feature data point? So schemas are defined as well. I mean, schemas are defined for feature groups. So there are like two different types of evolution the way we see it. One is data evolution. So I mean, like the data changes gets updated. For that, we use Apache UD that just today got promoted as a top-level Apache project. For schema changes themselves, or like you change like the meaning of a feature, that's what we have version 4. So the if you decide to add a new feature, delete a feature, or change the meaning, so like this feature instead of having being like 3 months old, it's actually looks at the past 6 months or something like that, then you have to create new versions. And the reason you create new versions is that if you write your jobs that pulls data out of the feature group of the feature store to be in such a way they always specify the versions, new breaking changes won't break the previous jobs. Basically, they will always keep working as long as you keep publishing data in those feature groups. Currently, if you want to create new versions, if you want to add new features, let's say, to the feature group, then you have to create the new versions. But we're working on a new set of APIs that allows you to allows you to basically do these changes without having to create new versions. Basically, changes like non-breaking changes. Such as adding features and so on. Is it possible to integrate feature store into Cloudera on-prem cluster? Yes. So you cannot run it on top of it, let's say, but you can run it on the side. As a company, we do have like users that run it we run the feature store and next to Hortonworks, well, now it's called Cloudera, cluster, and you can have feature engineering jobs running on external cluster, whether it's in this case, Cloudera, but it can also be Databricks, it can also be EMR if you're on the AWS, and then write data into the feature store. So you can interact from outside the feature store itself with the feature store. So to all that, as long as you have a Spark environment available, and you can write into the feature store. Any more questions? I think Gianmarco just disappeared.
Are we done?
Okay.
So if you have any other question, you can, I guess, maybe we can find a way to reach Fabio. You can ask me.
Yeah, if you have any questions, like if you need help or something, then I will suggest you use community. There's a bunch of more people that can help you with your issues and so on. Otherwise, you can reach me at fabio@logicalclocks.com. That's my email.
Thank you very much, Fabio.
Thank you.
You can, if you want to share these slides with us.
Yeah,
you can,
You
can send us the email. We will publish them together with the recording that will be available on YouTube.
Yeah. Okay. Great. I send it to you like now. Then so you can publish.